Okay, let's get this water boiling. Be back in a couple of minutes. Okay, looks like we got a good boil going. It might look a little different than what your pots or pans at home do because I have a piece of glass where it's really smooth inside and I'm using deionized water. But I've got a boil. We know based on what we've looked at in class and what you've been taught over many years, the temperature of that water right now is 100 degrees Celsius. You have been told, and rightly so, the highest temperature you can get for liquid water is going to be 100 degrees Celsius. Now, I understand this changes based on the atmospheric pressure. That's beyond the scope of what this video is about, but keep in mind the boiling point of water can fluctuate based on what the pressure of the atmosphere is. So, although I don't have a thermometer stuck in there, we're going to just assume that that's 100 degrees Celsius, close enough. Temperature, that water is going to stay 100 degrees until I boil away, or until it all boils away. But here's the thing. The maximum temperature for liquid water is 100 degrees Celsius. But once it's a gas, we can raise that temperature even higher. So what I have in this apparatus here is I've got the stopper sealing up the flask, and with a copper tubing. So I know it doesn't look like copper because it's old and it's been heated up and cooled down many times and oxidized. But what I'm going to do now is I'm going to heat up the gas. Now you can see that we have steam here coming out of this. This steam is probably a little bit below 100 degrees Celsius. And you can see it, so that means it's actually liquid water. It's just tiny, tiny little droplets of water that you can see. Clouds in the sky. You can see them because they're tiny little droplets, just a whole bunch of them all together that you can see. If it was a gas, you would not be able to see it. So let's turn this into a gas. It's pretty much a gas coming through the tube, but once it gets to the end here, it's cooled down enough to come out and be a liquid. So I'm going to take this propane torch, and we are going to heat up our water to a higher temperature. Now you can see here that we don't see that steam anymore. So we now have gaseous water coming out of that tube. And the temperature of that water is going to be whatever the temperature of that propane torch is burning at, which is probably several hundred degrees Celsius. I have to go look it up, but it's really hot. So we've taken our water that's at 100 degrees Celsius as a liquid, boiling, turning into a gas, coming through the tube, and we're not allowing that gas to cool down enough to turn back into a liquid. We've got this gas at several hundred degrees Celsius coming out as a gas at several hundred degrees Celsius. How hot? Well, let's see. I'm going to get this a little bit closer, heat that up a little bit more. And I'm going to take a piece of paper now and put it in front of that. There's no way I'm going to put my hand anywhere near that. But if I put that piece of paper up next to that, you can see that's not steam, that's smoke. Because I'm starting to burn and char the paper. So the temperature of that gas coming out is enough to get the paper to start to char. And if I got it even hotter, I'd get it to burn. Now I'm going to remove this. And one of the things you'll notice here is that we are going to start to see steam forming out here, far away from where that opening is. And you might be able to see it right now. It's starting to form right here, and it's going to get gradually closer and closer, because what's happening is that as this cools down, the temperature of the gaseous water that's inside of that tube is able to come out at lower and lower temperatures and turn back into a liquid. So again, you see there's a little gap between where the tubing ends and where you're going to start to see the steam, but the steam now is close to 100 degrees. I'm able to put my hand in it because it's not like it's the liquid in there. There's no way I would put my hand in a container full of water that's 100 degrees Celsius. But the water is so dispersed here, even though it's warm, it doesn't have enough energy, thermal energy, to cause it to burn for me. So that's how you can get water at temperatures above 100 degrees Celsius. You just have to have it in the gas phase first.